Okay, so we are going to look at a problem that allows us to practice this idea of stress and strain and using Young's modulus on a cable that's stretching. So imagine that you go to a circus and you see a circus performer swing down on a pendulum on a steel cable. And as he's swinging down right at the bottom, he's just barely missing the razor sharp blades that are on the floor for this death-defying performance. All right, so his feet are just above these razors. Okay, I guess it'd be more exciting if it was his head. So let's say his head is just above these razors. Okay, well, in order for the circus to know exactly where to place those razors, they have to understand how much this cable is going to stretch as this actor swings down. So they determine that in this uniform circular motion, at the very bottom, the force acting on that cable is 940 newtons. The cable is anchored 10 meters long, and we are going to place those razor blades just so that the cable cannot stretch more than a half of centimeter in order for our performer to be safe. Now we're going to say we're using a steel cable, and that has a Young's modulus of 2.0 times 10 to the 11th newtons per meter squared. So what diameter of cable do I need to go buy at the local hardware store? All right, so we're going to look at the relationship between our forces and how much that cable stretches by. So looking at the stress on the cable and the strain that it experiences. All right, so we are interested in the diameter, so we need to look at the area. We'll solve this equation for the area. We find the force divided by Young's modulus times the length over the change in length. So we're just solving for the area. And when we do that, we get 940 times the length of 10. Our Young's modulus was 2 times 10 to the 11th times a change in length of 0.005 meters. So we want to convert to meters so that we're all working in the same unit. All right, so when we solve for the area, we find that the area is 9.4 times 10 to the minus third meters squared. Now, that's the cross-sectional area. I need the diameter because wire is sold by its diameter. So how do I get the diameter? Well, we know that the area is equal to pi r squared. So I can solve for the radius. The radius, of course, is the square root of the area divided by pi. That equals our radius, and so we have 9.4 times 10 to the minus third divided by pi, and we get a radius of 1.7 times 10 to the minus third meters, or 1.7 millimeters. So that's our radius, and of course the diameter is equal to 2 times the radius, which is equal to 3.4 millimeters. So we need a 3.4 millimeter diameter cable to perform this death-defying feat. All right, so using this relationship between stress, the stress on the cable, and the strain, the amount it's stretched, so that we can have a fantastic circus performance. All right, good job.